should we use a high power, medium power, or a low power solution?
Okay, good question. Now you can see here, this is a high power solution, which is about 20 watts or 40 watts per carrier. This is the medium power, which is about 1 to 2 watts. And back here, we have the low power active dust solution. You can see here. Right, this small little remote unit is a low power, which is about half a watt. Right. So basically, when we deploy a dust solutions, there are three choices. You can have a high power, medium power, or low power solution. So what should be the most appropriate choice for your use? Right. So of course, with a high power solution, basically we're talking about 20 watts or 40 watts. So basically, you need to connect a passive infrastructure, a passive dust to distribute the high power. Right. So you're running traditional RF cables, right, and with antennas. Right. So that's how you deploy a high power or medium power solution. Whereas in the low power solution, you can see the antennas are already integrated within the remote unit. So that's why we call it active dust. There's no passive components. So therefore, the choice between high power and low power basically lies in the losses that you have in the feeder cable. Now, for example, in the past when we talk about 4G, the highest frequency that we encounter is only about 2,700 megahertz. So with that, we can still tolerate a passive dust, although the loss is a little bit high. But now when we look at C-band, the 3,500 megahertz band, either the N77, 78 or 79, right? The feeder losses are huge. So that makes it impractical for us to use a passive infrastructure together with a high power solution, because the losses in the dust is way too much, unless you use large feeder cables, which will increase the cost of installation. And also, in terms of 5G today, right, we are talking a lot about 4x4 MIMO to increase the capacity of the base station. Right. So with 4x4 MIMO means if I use a high power solution with a passive dust, I need to run 4 feeder cables, right, over large distances. So that makes the installation cost very high and also very prone to PIM, passive intermodulation issues. But with the active dust, it's just simply laying a hybrid cable with 4 fibers with the power cables, right? And you can deliver 4x4 MIMO with unlimited bandwidth. So, and of course, in the low power solution, there's also another very important advantage that the high power cannot have. Now, on the uplink, as you know, in stadiums or whatever, we require users, or rather users would be expecting to upload huge amounts of data, video, or photographs into their Facebook account and so on. So a low power solution, because the amplifiers and the antennas are close together, it actually gives a much better uplink performance. Whereas a passive dust, a high power passive dust will have a high power remote unit will have a high passive dust loss, and that actually makes the uplink throughput slower. So these are the key differences between deploying the active dust or the high power solution. Primarily depends on the 5G requirements, the MIMO requirements, and the uplink performance of your system.